Hello, this is Real World Audio, and now I'm going to answer a few questions about the measurements videos which are coming up. And I'm doing these so that to make measurements accessible for you. It is not my intention to start a war between whether tube amps or solid state amps are better. It is everyone's personal judgment and decision what works better for you, and also their capabilities are very largely impacted by what kind of loudspeakers, what kind of system you use them with. So uh, it's it's quite complex, and that's why I started this channel, because it is a really complex issue, and it cannot be answered by a simple yes or no. uh, I'm giving you pointers, I'm giving you how things work, and everyone can put together a system, or I would say most of you already have systems at home and are, I assume, are curious about if you change it, how will it change? And that's why in my previous videos I already have warned everyone that if you like how your system sounds, then really beware about changing anything in it, because all I can tell you that is, if you want a radical change, a big change, then you are up for a very bumpy road, and it might not be a very short path, and the more responsive components you have in your system, the tougher the road gets, and the tougher calls you will have to make, and wrong choices or unsuitable, there are no wrong choices, but unsuitable components will start to make more and more of their say, and you will be able to hear more and more of the weaknesses of the limiting components once you start making your system more sensitive and more responsive. So answering the comment, Tiago's comment, first one, is that I imagine that once you understand the concept, you can check for yourself how other amplifiers compare to the examples you will analyze. For one, I am very curious to check the first watt J2 and C3. And yes, this is why I'm making these videos, to give you the knowledge on when you look for the specifications for an amplifier, then you will be able to tell for yourself whether you have been given useful specifications, and what can you expect from that, what will those tell you. And this was the main big idea behind this series, and that's what we'll go through tomorrow on Monday. I will show you how to interpret the square wave, which will tell you much more than the THD figures, which are, I would say, useful if you know a lot about THD, but if you don't know anything about it, you are not consciously judging THD based on the topology you have, then THD is totally useless. So whether an amplifier has 1% THD or 0.0005% THD, it will not translate to anything meaningful in the sonics of that amplifier if you do not know what topology that amplifier is and what sort of internal devices are used, methods are used to achieve those THD values. So because THD can be low because of the high linearity of the devices used in that amplifier, and then it's a naturally low THD, that's what you want. and it can be artificially low, created by feedback, and that's what you do not want. I'm not saying that it's something bad, but it's very different. So naturally low THD is like having spring water, and artificially lower THD is like having bottled water. That may be, and in that case, you don't know what you are drinking. Was it bottled? It could be still bottled from spring water, but maybe it's bottled tap water or bottled purified sewage water. You don't know. The THD value will not tell you which case you are presented with, and that's why you will need to learn more about the amplifiers. And when you look at the square waves, that will give you the opportunity to be able to tell, okay, what is this amp doing? And then you can tell more about whether you are faced with a naturally low THD situation, or you are being provided with purified sewage water, basically. So maybe these analogies may seem harsh to all of us, but they are not. The situation is so diverse, and the errors that the amplifiers introduce during the amplification process do vary to this extent that the unfiltered, which is the feedback-less amplification product of the amplifier, can range from spring water to sewage water quality. And feedback is used to clean it up in such a way that it's potable. So thank you, Tiago, for your question, and I hope I have answered Eddie's question as well. And his comment is much more complex and would take much longer time to answer, but the beginning of the video was for you, Eddie, is that when you change one component in the system, then you are up for a very rough road. But I see that you are taking very good choices here, and indeed having a tube preamp with a solid state power amplifier is a workable road. And it's for example, if you are happy, and I'm generally talking about not just to you, Eddie, but for everyone, that you are happy with your solid state amp, but just you want a tad bit more naturalness with piano, with the vocals, with instruments, but you are happy with the power delivery of the amp, then usually just having a tube preamp will help the situation. And that's because the solid state amplifiers do a really good job at providing enough current to drive the loudspeakers, but they do a very poor job at the voltage amplification, which is required to take the low level signal to the level where the output transistors can drive the loudspeaker. So that's why it's a good idea to give that job to a vacuum tube to create a voltage amplification. So I hope everyone is tuned in for tomorrow, when we'll have a look at what square waves look like, how they are produced, and why is it important to look at them, and what you can glean from those measurements. So thank you for tuning in. See you tomorrow. Bye bye.